Hello viewers, welcome to our channel Career Prep. In this video, we'll solve a few miscellaneous problems on the topic trains so that you can have a better understanding of the concept. Since questions based on this topic are most frequently asked in competitive exams, it makes sense to understand the concept well. These questions are the ones where marks can be scored easily if practiced well. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. A train running at a speed of 60 kilometers per hour crosses a pole in 9 seconds. What is the length of the train? You're given 4 options here and you have to find out which of these options is the correct one. So it's given that the speed of the train is 60 kilometers per hour. Now, since all the options are given in meters, let's convert this kilometers per hour to meters per second. To do that, we have to multiply this by 5 by 18. So, 60 kilometers per hour is nothing but 60 multiplied by 5 by 18 meters per second, which is nothing but 50 by 3 meters per second. Now it's given that the time taken by the train to cross the pole is 9 seconds and we're asked to find the length of the train. Now we know that time is equal to distance upon speed. Since the pole is of negligible length as compared to the length of the train, distance will be nothing but the length of the train. Since the pole is stationary, speed will be the speed of the train. So now we have the formula as time taken by the train to cross a pole is equal to length of the train divided by speed of the train. We know that time is 9 seconds and speed of the train is 50 by 3 meters per second. Substituting these values in the formula, we get 9 is equal to length of train divided by 50 by 3. So length of the train is equal to 9 multiplied by 50 by 3, which is nothing but 150 meters. So length of the train is 150 meters. So the correct answer is option D, 150 meters. A train 125 meters long passes a man running at 5 kilometers per hour in the same direction in which the train is going in 10 seconds. What is the speed of the train? You're given 4 options here and you have to find out which of these options is the correct one. So here it's given that the length of the train is 125 meters. Since all the options are given in kilometers per hour, let's convert this meters to kilometers. We know that 1000 meters is 1 kilometer. So 125 meters is 125 divided by 1000 kilometer, which is nothing but 1 by 8 kilometers. Length of the man is negligible as compared to the length of the train. It's given that the speed of the man is 5 kilometers per hour and we are asked to find the speed of the train. It's also given that the train passes the running man in 10 seconds. Since all the options are given in kilometers per hour, let's convert the seconds to hours. We know that 3600 seconds is 1 hour. So 10 seconds is nothing but 10 divided by 3600 hours, which is nothing but 1 by 360 hours. We know that time is equal to distance divided by speed. Since length of the man is negligible, distance will be nothing but the length of the train. Since both the train and the man are moving simultaneously in the same direction, speed will be the relative speed. Since both the train and the man are moving in the same direction, relative speed will be the difference between the speeds of the train and the man. So relative speed is equal to speed of the train minus speed of the man. We know that speed of the man is 5 kilometers per hour. So relative speed is equal to speed of train minus 5 kilometers per hour. So now we have the formula for time taken by the train to cross a running man is equal to length of the train divided by relative speed. It's given that time is 1 by 360 hour, length of the train is 1 by 8 kilometers, and we know that the relative speed is speed of train minus 5 kilometers per hour. Let's substitute all these values in the formula. So now we have 1 by 360 is equal to 1 by 8 divided by speed of train minus 5. On cross multiplication, we get speed of train minus 5 is equal to 1 by 8 multiplied by 360. On solving this, we get speed of train as 50 kilometers per hour. So the correct answer is option B, 50 kilometers per hour. A train passes a station platform in 36 seconds and a man standing on the platform in 20 seconds. If the speed of the train is 54 kilometers per hour, what is the length of the platform? You are given four options here and you have to find out which of these options is the correct one. Now it's given that the time taken by the train to cross the platform is 36 seconds and the time taken by the train to cross the man on the platform is 20 seconds. It's given that the speed of the train is 54 kilometers per hour. Since all the options are given in meters, let's convert this kilometers per hour to meters per second. To do that, we have to multiply this with 5 by 18. So 54 kilometers per hour is nothing but 54 multiplied by 5 by 18 meters per second, which on solving will give us 15 meters per second. So speed of the train is 15 meters per second. And we are asked to find the length of the platform. Now let the length of the platform be x meters. We know that time is equal to distance divided by speed. Now, since the platform is of considerable length, distance will be equal to length of train plus length of platform. Since the platform is stationary, speed will be the speed of the train. So now we have the formula for time taken by the train to pass a platform is equal to length of train plus length of platform divided by speed of train. Now in the problem, it's given the time taken by the train to pass the platform is given, speed of the train is given. So if we find out the length of the train, then we can easily calculate the length of the platform. So first let's find out the length of the train. Now we know that time is equal to distance upon speed. Now to find the length of the train, let's use the other information given in the question. That is, time taken to cross the man on the platform is 20 seconds. So now we know that time is equal to distance divided by speed. Now since length of the man is negligible as compared to the train, distance will be nothing but the length of the train. Since the man is stationary, speed will be the speed of the train. So time taken by the train to cross the man on the platform is equal to length of the train divided by speed of the train. Now it's given that time taken by the train to cross the man on the platform is 20 seconds. We have to find the length of the train. It's given that speed of the train is 15 meters per second. Substituting all these values in this formula, we can find the length of the train. So 20 is equal to length of the train divided by 15. On cross multiplication, we get length of the train is equal to 20 multiplied by 15, which is nothing but 300 meters. So length of the train is 300 meters. Now that we know the length of the train, let's calculate the length of the platform. We know that the time taken by the train to cross the platform is 36 seconds. We know that the speed of the train is 15 meters per second. We have found out that the length of the train is 300 meters. So let's now find the length of the platform using the formula time is equal to length of train plus length of platform divided by speed of train. Let's substitute all the known values in this formula. So now we have 36 is equal to 300 plus x divided by 15. On cross multiplication, we get 300 plus x is equal to 36 multiplied by 15. On solving this, we get x is equal to 240 meters. So the length of the platform is 240 meters. So the correct answer is option B, 240 meters. A train crosses 210 and 122-meter long tunnels in 25 and 17 seconds respectively. Find the length of the train and speed of the train. Here you are given four options and you have to find out which of these options is the correct one. So here you are asked to find the length of the train and speed of the train. So let L be the length of the train and V be the speed of the train. We know that time is equal to distance divided by speed. Now for the tunnels, since the length of the tunnel is considerable, distance will be equal to length of the train plus length of the tunnel. Since tunnel is stationary, speed will be the speed of the train. So now we have the formula for time taken by the train to cross the tunnel is equal to length of the train plus length of the tunnel divided by speed of the train. Now for the first tunnel, it's given that the time taken by the train to cross the first tunnel is 25 seconds and length of the tunnel is 210 meters. Let's substitute these values in this formula. So we have 25 is equal to L plus 210 divided by V. Since uh, we do not know the length of the train, we have assumed it as L, and we do not know the speed of the train and we have assumed it as V. Now on cross multiplication, here we get L plus 210 is equal to 25V. This is the first equation. Now let's move on to the second tunnel. For the second tunnel, it's given that the time taken by the train to cross the second tunnel is 17 seconds and length of the tunnel is 122 meters. Now now we have assumed that the length of the train is L and speed of the train is V. So now let's substitute all these values in this formula for the second tunnel. So we have 17 is equal to L plus 122 divided by V. On cross multiplication, we get L plus 122 is equal to 17V. This is the second equation. Now subtract the second equation from the first equation. When you subtract the second equation from the first equation, L and L will get cancelled and 210 minus 122 is 88 and 25V minus 17V is 8V. So on subtracting equation 2 from equation 1, we get 88 is equal to 8V. So V is equal to 11 meters per second. Now since we know the value of V, let's substitute the value of V in, let's put the value of V in equation 1. Now putting V is equal to 11 in equation 1, we get L plus 210 is equal to 25 multiplied by 11. On solving this, we get L is equal to 65. That is, length of the train is 65 meters. So now we know that the speed of the train is 11 meters per second and length of the train is 65 meters. So the correct answer is option B, 1165. Two trains running in opposite directions cross a man standing on the platform in 27 seconds and 17 seconds respectively, and they cross each other in 23 seconds. Find the ratio of their speeds. Here you are given four options and you have to find out which of these options is the correct one. Now it's given that time taken by the first train to cross the man on the platform is 27 seconds. Time taken by the second train to cross the man on the platform is 17 seconds. Time taken for the trains to cross each other is 23 seconds. Now we are asked to find the ratio of the speeds of the two trains. So let the speeds of the two trains be x meters per second and y meters per second respectively. Now we know that time is equal to distance divided by speed. The trains are passing a man standing on the platform. Since the length of the man is negligible as compared to the train, distance would be nothing but the length of the train. Since the man is stationary, speed will be the speed of the train. So now time taken by the two trains to cross the man standing on the platform is equal to length of the train divided by speed of the train. Now for the first train, it's given that time is 27 seconds. We have assumed that the speed of the first train is x meters per second. So let's substitute these in this formula. So for the first train, 27 is equal to length of the train divided by x. So length of the first train is equal to 27x meters. Now for the second train, time is given as 17 seconds and we have assumed the speed of the train as y meters per second. Let's substitute these values in this formula. So for the second train, 17 is equal to length of the train divided by y. So length of the second train is equal to 17y meters. We'll continue solving this problem in the next slide. Now it's given that the time taken for the trains to cross each other is 23 seconds. As we know, time is equal to distance divided by speed. Now since both the trains have considerable length, distance will be length of the first train plus length of the second train. Since both the trains are running in opposite directions, speed will be relative speed. Since both the trains are running in opposite directions, the relative speed will be the sum of the speeds of the two trains. So relative speed will be equal to speed of one train plus speed of the other train. Now we have assumed the speed of one train is x meters per second and speed of the other train is y meters per second. So here relative speed is equal to x plus y meters per second. Now we know that time taken by the trains to cross each other is 23 seconds. Relative speed is x plus y meters per second. Length of first train is 27x and length of second train is 17y. Let's substitute all these values in this formula. So we have 23 is equal to 27x plus 17y divided by x plus y. On solving this, we get x by y is equal to 3 by 2. So the ratio of the speeds of the trains is 3 is to 2. So the correct answer is option B, 3 is to 2. A jogger running at 9 kilometers per hour alongside a railway track is 240 meters ahead of the engine of a 120 meters long train running at 45 kilometers per hour in the same direction. In how much time will the train pass the jogger? You are given four options here and you have to find out which of these options is the correct one. Now it's given that speed of the jogger is 9 kilometers per hour. Speed of the train is 45 kilometers per hour. Length of the train is 120 meters. We are asked to find in how much time the train will pass the jogger completely. Now we know that time is equal to distance divided by speed. It's given that the jogger is 240 meters ahead of the engine of the train. So the distance to be covered by the train to pass the jogger completely is equal to 240 plus the length of the train, which is 120. So 240 plus 120 is 360 meters. So distance to be covered is 360 meters. Now the jogger is running in the same direction as the train. So speed is relative speed. Now since the jogger and the train are going in the same direction, relative speed is the difference of the of two speeds. So relative speed is equal to 45 minus 9 kilometers per hour, which is 36 kilometers per hour. But since all the options are given in seconds, we'll convert this kilometer per hour to meters per second. To do this, we have to multiply this by 5 by 18. So 36 kilometers per hour is nothing but 36 multiplied by 5 by 18 meters per second. On solving this, we get the relative speed as 10 meters per second. Now we know that the distance uh, to be traveled by the train to pass the jogger completely is 360 meters, and the relative speed is 10 meters per second. Now, so now the time is equal to 360 divided by distance divided by speed. So 360 divided by 10, which is nothing but 36 seconds. So the train will pass the jogger completely in 36 seconds. So the correct answer is option C, 36 seconds. A man sitting in a train which is running at 50 kilometers per hour observes that a goods train running in opposite direction takes 9 seconds to pass him. If the goods train is 280 meters long, find its speed. You are given four options here and you have to find out which of these options is the correct one. So here you are asked to find the speed of the goods train. So let the speed of the goods train be x kilometers per hour. Now, the goods train passes a man sitting in a train which is running at 50 kilometers per hour. So, effectively, the man's speed is considered to be the same as the train in which he is sitting. So, the man's speed is effectively also 50 kilometers per hour. Now we know that time is equal to distance divided by speed. It's given that the goods train takes 9 seconds to pass the man. So time is equal to 9 seconds. Now since the length of the man is negligible, distance is equal to the length of the goods train, which is 280 meters. Now, since the goods train and the man are traveling in opposite directions simultaneously, speed is relative speed. And since the goods train and the man are traveling in opposite directions, the relative speed is the sum of the speeds of the goods train and the man. So, relative speed is equal to 50 plus x kilometers per hour. Now, since time is in seconds and distance is in meters, we'll convert this kilometer per hour to meters per second. We can do this by multiplying this by 5 by 18. So 50 plus x kilometers per hour is nothing but 50 plus x multiplied by 5 by 18 meters per second. Now, the time taken by the goods train to pass a man sitting in a train is equal to length of train divided by relative speed. We know that the time is 9 seconds, length of the goods train is 280 meters, and relative speed is uh, 50 plus 6 multiplied by 5 by 18 meters per second. Substituting all this in this formula, we get 9 is equal to 280 divided by 50 plus x multiplied by 5 by 18. On solving this, we get x is equal to 62 kilometers per hour. So the speed of the goods train is 62 kilometers per hour. The correct answer is option D, 62 kilometers per hour. Two trains P and Q are 110 kilometers apart on a straight track. One train starts from P at 7 a.m. and travels towards Q at 20 kilometers per hour. Another train starts from Q at 8 a.m. and travels towards P at a speed of 25 kilometers per hour. At what time will they meet? You are given four options and you have to find out which of these options is the correct one. Now it's given that one train starts from P towards Q at 7 a.m. at a speed of 20 kilometers per hour. The second train starts from Q towards P at 8 a.m. at a speed of 25 kilometers per hour. So the first train starts at 7 a.m. and the second train starts at 8 a.m. So the first train has started 1 hour earlier than the second train. Since the speed of the first train is 20 kilometers per hour, it means that in that 1 hour, the first train would have covered a distance of 20 kilometers from P. Now, at 7 a.m., the distance between the two trains is 110 kilometers. After 1 hour, that is at 8 a.m., the distance between the two trains is 110 minus 20 because the first train has uh, covered a distance of 20 kilometers in the first hour. So the distance between the two trains at 8 a.m. is 110 minus 20, which is 90 kilometers. So at 8 a.m. the distance between the two trains is 90 kilometers. Now it's given that both the trains travel towards each other. So relative speed is sum of the speeds, which is 20 plus 25, which is 45 kilometers per hour. Now we are asked to find at what time will the two trains meet. So time taken by the two trains to meet is equal to distance divided by relative speed. We know that the distance between the two trains at 8 a.m. is 90 kilometers and the relative speed is 45 kilometers per hour. Substituting these values in the formula, we get time taken by the trains to meet is equal to 90 divided by 45, which is 2 hours. Therefore, the two trains meet each other 2 hours after 8 o'clock, that is at 10 a.m. So the correct answer is option B, 10. A train traveling with a speed of 60 kilometers per hour catches another train traveling in the same direction and then leaves it 120 meters behind in 18 seconds. What is the speed of the second train? You are given four options here and you have to find out which of these options is the correct one. Now it's given that speed of the first train is 60 kilometers per hour. Now let's convert this kilometer per hour to meters per second by multiplying with 5 by 18. So 60 kilometers per hour is nothing but 60 multiplied by 5 by 18, which is 50 by 3 meters per second. Now we are asked to find the speed of the second train. So let the speed of the second train be x meters per second. Now it's given that the first train leaves the second train 120 meters behind in 18 seconds. This means the first train is faster than the second train by 120 by 18 meters per second. That is, the difference in the speeds of the two trains is 120 by 18 meters per second. Now we know that the speed of the first train is 50 by 3 meters per second. Speed of the second train is x meters per second. And the difference in the speeds of the two trains is 120 by 18 meters per second. So the difference of the difference in the speeds is given by 15 by 3 minus x is equal to 120 by 18. On cross multiplication and solving, we get x is equal to 10 meters per second. But since all the options are given in kilometers per hour, let's convert this meter per second to kilometers per hour by multiplying with 18 by 5. So 10 meters per second is nothing but 10 multiplied by 18 by 5, which is 36 kilometers per hour. So the speed of the second train is 36 kilometers per hour. So the correct answer is option C, 36 kilometers per hour. A goods train leaves a station at a certain time and at a fixed speed. After 8 hours, an express train leaves the same station and moves in the same direction at a uniform speed of 120 kilometers per hour. This express train catches up the goods train in 7 hours. Find the speed of the goods train. Here you are given 4 options and you have to find out which of these options is the correct one. So here you are asked to find the speed of the goods train. So let the speed of the goods train be x kilometers per hour. It's given that the express train starts 8 hours after the goods train and moves in the same direction and catches up the goods train in 7 hours. So the goods train has traveled for 8 plus 7, that is 15 hours, and the express train has traveled for only 7 hours. Now, since the express train catches up with the goods train, the distance covered by the goods train in 15 hours is equal to distance covered by the express train in 7 hours. Now we know that distance is equal to time multiplied by speed. So for the goods train, time is 15 hours and speed is assumed to be x kilometers per hour. For the express train, time is 7 hours and speed is given as 120 kilometers per hour. So dis distance covered by goods train in 15 hours is equal to distance covered by express train in 7 hours, means 15x is equal to 7 multiplied by 120. On solving this, we get x is equal to 56. So the speed of the goods train is 56 kilometers per hour. So the correct answer is option C, 56. The ratio of the length of two trains x and y is 4 is to 7, and the ratio of the time taken by both the trains to cross a man standing on a platform is 2 is to 3. If the speed of the train x is 36 kilometers per hour, find the speed of the train y in meters per second. Here you are given 5 options and you have to find out which of these options is the correct one. Now it's given that the ratio of the length of the two trains x and y is 4 is to y. So if the length of train x is 4a, then the length of train y will be 7a. It's also given that the ratio of the time taken by both the trains to cross a man standing on a platform is 2 is to 3. So if the time taken by train X to cross the man standing on the platform is 2b, then time taken by train Y to cross the man standing on the platform will be 3b. We know that speed of a train is equal to uh, distance divided by time. So speed of train X is equal to 4a divided by 2b, and speed of train Y is equal to 7a divided by 3b. So now the ratio of the speeds of train x and y is equal to 4a by 2b divided by 7a by 3b. On solving this, we get the ratio of the speeds as 6 is to 7. This means that if the speed of train x is 6 kilometers per hour, then speed of train y will be 7 kilometers per hour. Now we are asked to find the speed of train Y, and speed of train X is given as 36 kilometers per hour. So if the speed of train X is 6 kilometers per hour, then the speed of train Y will be 7 kilometers per hour. If the speed of train X is 36 kilometers per hour, then speed of train Y will be 36 divided by 6 multiplied by 7, which is nothing but 42 kilometers per hour. Since we are asked to find the speed of train y in meters per second, let's convert this kilometer per hour to meters per second by multiplying this with 5 by 18. So 42 kilometers per hour is nothing but 42 multiplied by 5 by 18, which is nothing but 35 by 3 meters per second. So speed of train y is 35 by 3 meters per second. So the correct answer is option A, 35 by 3 meters per second. Viewers, please go through this video till you have understood the concept clearly. Please do watch all our videos on boats and streams. If you have liked this video, please like, subscribe and share this video. Thank you.